Discover Next, the studio for facades and design. Next is the platform for innovation in the field of building envelopes, for inspiration, information and communication. Initiated by Vicona, with leading industry experts as Next partners. Next is a unique concept which is constantly evolving and bringing the future of cities to life.
Guten Tag, good evening, salam alaikum, a warm welcome for the 7th International Next Facade Summit. Today is a very, very special day. We have a brilliant audience who have assembled here at the Next Frankfurt studio. And I've been told we have 900 registrations from 74 countries. So for you, the audience who are logging in from different parts of the world, and for you, ladies and gentlemen, a very, very good evening. A big round of applause for you for taking time and to join us on the 7th Next Summit. And today is also a very special day. Our panel of speakers is star-studded women leaders from the architecture and facade industry. So a big round of applause for our special panel of speakers who have come all the way from Dubai, from Germany, from Oslo. A big round of applause to our panel speakers. International reports have said the amount of women in construction is only 14%. However, last year alone, 34% of women graduating from universities have moved into construction. That is an inspiring trend, and we are so proud and humbled and honored to have all of you women leaders to speak about your profession, your projects, and we're looking forward to have your inspiration today in this 7th International Next Summit. So, without further ado, I would like to invite our first speaker, a very, very special friend of mine. She graduated as an architect in 2001 in Brazil and gained her first experience working in Brazil and Australia, focusing on residential and retail projects. 2004, she took a master's degree in structural and construction engineering at the Griffith University in Australia and worked as a structural engineer for 5 years in Australia, UK, and the Middle East. Today, she is the technical director at Mainhardt Facade Technology, a leading design and engineering firm having offices throughout Asia, Middle East, Europe, and Australia with over 200 facade specialists working for them. Today, Michelle is going to talk about a very, very special project which is making a lot of noise on this new 2023. Please help me welcome Michelle Bachelard, Technical Director of Mainhardt Facade.
Thank you very much. Can you guys hear me okay? Yeah. Thank you very much, Arvin. I would like to take this opportunity to thank for the opportunity to be here. I was very excited. I've never been to Frankfurt, so I was very excited to come over until I checked the weather prediction. Then I was like, oh, it's going to be so cold. So as Arvin said, I am the technical director for Mainhardt Facade Technology in Dubai. And today I'm going to be present one project that I've personally been working on for the last 3 years, which is the Shebara Hotel in Saudi Arabia. So the Shebara Island, it's an island off the west coast of Saudi Arabia. It's about 45 minutes boat ride from the mainland, and it's a completely off-grid island. So this resort, this development incorporates, as part of the development, a solar farm that powers the whole electricity for the development. It also has a solar-powered desalination plant that supplies the fresh water. And they also have a small recycling plant to minimize the amount of waste that goes into the mainland. The resort, it's a hyper-luxurious hotel, 73 keys. And the resort is spread horizontally across the island in the form of several individual assets. So there's a bunch of amenity assets, such as the arrival lobby, specialty restaurants, spa, fitness center, kids club, and so on. And the the accommodation assets, which they take form as overwater villas and beach villas. Today, this presentation, I'm going to be focusing on the design and the fabrication and construction of a typical overwater one-bedroom villa. So the design approach for the villa was to minimize the footprint, the environmental footprint of the villa. So the whole villa cantilevers over the seabed, the coral reefs, and it touches the ground just on a minimum footprint, just over a few square meters. The shape of the villa is an ellipsoidal shape with a few cut-out openings at the terrace and at the entrance on the other side. The roof incorporates a skylight and also an opening for an access hatch. The one-bedroom villa typical size is 18 meters in diameter and 6 meters in height. So I'll be talking about the whole evolution from the design process all the way to construction. So the inspiration for the facade design was to have a very reflective finish on the facade, because what the architect wanted was the facade to reflect the surroundings and the buildings to merge with the environment. So the buildings would go almost unnoticed. So it was very important for us to come up with the correct facade system and facade material to achieve this vision. So in the initial design stages, the structural approach for the shell of this villa was to have an FRP structure, carbon reinforced polymer structure. So in the very early design stages, we were looking at options of how to finish this carbon fiber structure. So we looked at different coatings. We looked at automotive painting. We looked at gel coatings. We looked at different ways to clad this FRP. So we've looked at having very small stainless steel tiles, flat tiles. We looked at having long single curved stripes. We've looked at having larger tiles, double curved in shape. And there was mock-ups prepared. Oops, sorry. There was mock-up prepared for all these different options that we were looking at. When the mock-ups were presented, the architect basically rejected them all because they all failed to meet the design intent. What they wanted was a completely seamless structure. They wanted a polished, mirror-finished, seamless structure. So the paint wasn't reflected enough, and the other options, they have too many joints, basically. So then we started really looking into having one singular shell made out of stainless steel that was completely seamless. Obviously, we had never done anything like this before, so we started looking for precedent constructions that had this similar approach. So everything that we found at the time was either sculpture-like structures or constructions that was non-habitable. So we took this very famous, the beam in Chicago, Cloud 9, I'm sure you're all familiar with, and we looked at what was the construction methodology of this. So we found out that the beam was made out of 168 stainless steel plates, 10 millimeters thick, with reinforcement at the back. The total size was about 10 meters by 20 and 30 meters high. And there was over 700 meters of welding seams in this structure. So the panels were brought up, everything was welded together, and then they've built a tent on site, and 24 workers spent just over 12 months polishing the structure to come up with this look. So after studying this project, we realized we had a very, very big challenge. We had to come up with a design for a similar construction, but much lighter and with a much quicker construction period. So we started our design by trying to come up with the most efficient thickness for this shell. So when we started doing the study, we've realized that the thickness of the shell was not going to be a result of the structural requirements alone. We had to also take into consideration the thickness to withstand the fabrication process, because the sheets needed to be double curved, needed to be welded, needed to be grinded, needed to be polished. So we needed to make sure that we had enough thickness there to withstand this fabrication process, but make sure that it was thin enough so it was light for the construction. Another thing that played a big role on determining the thickness of the shell was the visual appearance. So obviously, the visual aspect of this shell had a tremendous importance on the whole achieving the design concept by the architect. So what was driving the deflection criteria for the shell was really the visual aspect. In order to make sure that we had a shell that was thick enough that wouldn't deflect and cause any visual distortions with the images reflected, we ran a number of different analyses, testing different supporting arrangements, layout, and different thickness. And then we would export the deflected shape into a rendering software and render the deflected shape with different backgrounds to understand what the deflection would do in a real scenario. So we were mainly testing thermal loads. That was one of our main worries at the time, was the thermal loads, because obviously, you know, with the temperatures in the Middle East, the shell would heat up and contract a lot. So this is the structural arrangement that we finally used. So just to show you, firstly, we've rendered the deflected shape of the shell onto a zebra background, and obviously all the deformation is super apparent when you have the zebra background. But then we also tested something that would be a lot more closely to the final site condition, which is, you know, reflecting the sky. So we tested clear sky and cloudy sky. And we've gone through a lot of rounds with the architect, and finally he said that this was acceptable in terms of visual distortions. One thing that we were very lucky as well is that, as you can see, the majority of the deformations happen at the top and at the bottom of the shell, where the geometry is a little bit flatter. And at those areas, top and the belly, you know, the shell will be reflecting either the sky or the water below. So any deformation is not really visible. At the perimeter of the shell, where it reflects the adjacent buildings and, you know, the surroundings, the structure is very stiff because of the curvature. So the deformations there, you know, the deformations that cause the deflections that would cause the deformation almost unnoticeable on the sides. So that was lucky that we had this shape. Another thing that we've considered on the design, obviously, is, and that was part of the engineering as well, is that we had to make sure that the connections were flexible enough to allow movement. So again, coming to, you know, applying the thermal load. So we had to make sure that, you know, the connection points will not restrain the shell from moving, which could end up causing deformation when you looked on the shell from the outside. So all the connection points, they are fitted in with Teflon pads, which allow sliding of the connection and a minor compression, which enables the shell to expand and contract almost independently from the supporting structure. Also, that releases a lot of the stresses. In terms of the specification, obviously, with most projects in Dubai, we always specify a number of tests to verify the design of the facade. On this project, we've also specified a bunch of tests. So a lot of the tests were standard tests. So we had some tests that were carried out on site, and we made the contractor, you know, show rectification works were required to make sure that this could also be rectified on site. So there was impact tests, scratch tests, indentation tests. Then also, you know, load tests on the welds, on the connections, on the anchor points for the rope access system. We also had a lot of surface salt spray tests, so weathering tests to make sure that, you know, the stainless steel wouldn't corrode over time. So these are some pictures of samples that were exposed to 1,000 hours of salt spray test. We also had, obviously, facade tests, you know, air, water penetration. But one thing that was of big concern for us was how would this shell behave under temperature? because temperature is something that it's real, especially in the Middle East. There's a big variance in temperature between winter and summer, and sometimes even between day and night. So we were very concerned about how would this shell behave under temperature, and if there was any effects that we hadn't taken into account during design. Simply, I think the major concern is that we normally design standard facade systems, and on a standard facade systems you have panels, individual panels. In the panels you have a joint around the panel. So, you always design your joint to make sure that it can accommodate any building movements or any thermal expansions. So it's a flexible facade. In this case, we have a singular shell that doesn't have any joints. So we said, okay, we need to do a thermal test on the shell. And it needs to be full scale because, if you test just part of it, then obviously the shell has all the space to expand and contract. So that took a few rounds with contractors until we found a lab that agreed to do a full scale test. So the test was, very much the test regime was developed specifically for this project. But we've used as a base the American thermal cycling test, the AMA 501. So we subjected a shell. The idea was to subject a full-size villa to cycles of temperature, but differently from the standard thermocycling test, where you normally record of how the panels behave under the thermocycling. What we wanted to see here, what we were interested in, is deformation in terms of visual aspect, and whether this shell would generate any noises. This was something that, especially myself, I was really concerned about, because it's something that you can't really engineer, and we couldn't predict. So we said, okay, this is going to be a 6-star hotel. Temperature changes is always early morning, late afternoon. Imagine if the guy's there laying on his villa, and they suddenly it's like, pack, pack. So we really we basically convinced the client that yes, we need to test that. So this test, we had video cameras fitted out on all corners of the chamber, and we had also audio equipment fitted inside the villa to record any noises that could have been generated during the test. So this is some pictures of the test. So. And apparently, this is the largest thermocycling test ever done. So this is the sample. It was on the manufacturing facility. So the lab had actually to go to manufacturing facility and build their chamber there. This is the structure still for the chamber. The chamber was then clad with thermal panels. There was huge air conditioning equipment connected to the inside of the villa, because the inside of the villa we kept during the whole test at a temperature of 24 degrees. And then there was also air conditioning equipment connected to the inside the chamber to create the cooling cycles. You can see there's some cables there. Those are thermal sensors that were attached to the shell. There was 500 light bulbs to create the heating cycle. So the cycles were from 5 degrees to 85 degrees. And this is some of the equipment. So the shell was completely fitted out. This was also the mock-up, so it's completely all the fit out, glazing, everything. So inside the shell kept at 24 degrees. The external went to the thermocycling. So we had cameras everywhere that caught images of the whole shell during the entire test, in the audio equipment. And there was also vibration sensors placed at different areas to enable the team to localize the source of sound, if any. Also, the chamber, if you look, the inside of the chamber was painted with vertical lines, so it would be easy to detect any visual distortion on the shell. So the test took over 4 days. And thankfully, there was no recorded noises, and the visual distortions that were recorded were very minimal and acceptable. Okay, moving on, talk a little bit more of the design. So the shell, the cleaning and the access for the shell is done by rope access. We have at the entrance, so that opening there is the entrance, and there's a little service room just before you get into the villa that gives access to an access hatch. There was a lot of concern from the architect during the whole design process that we could not damage this seamless appearance. So everything had to be always very thoughtful in terms of keeping this design intent. So the access hatch was customized to take the double curve shape of the shell. All the anchor points for the rope access was also incorporated little cover plate to make sure that they were not visible from outside. There's a skylight, so there's a few, the one-bedroom villa has one skylight, and the two-bedroom, three-bedroom, they have two skylights. But the skylight, it was placed, there was a lot of study done from our side to make sure we placed the skylight at a location where we could use a single curved glass on the double curved surface. And the glass was actually manufactured flat and then double curved in position. So this, obviously, this whole exercise made a lot of difference on the cost, because originally it was just a double curved glass. The facade system, so the terrace is got a big glazing at the front with a slimline door system, Vitroxa, and the facade, the fixed panels on the sides and on the top is Vicona system, coincidentally. But the reason why I'm talking about this sliding door is because I think whoever is familiar with the system, you know that the flatness of the track is really important for the function of the system. This system relies on bearings on the track. So any deviation or any deflection of the track, that means that, potentially your door, it could impact the operation of your door. Now, the approach for the construction of these shells or these villas was completely off-site manufacturing. So all those villas have been manufactured in Dubai, and then they've been put on the back of a barge and shipped to the site. Which means that when we were doing the design for those elements, we had to take into account a bunch of different deflected shapes for the base structure. So when the villas were under fabrication, they were supported by a temporary frame, and it was supported in 4 points. When the villa was ready, then it was loaded onto a barge, also supported onto this temporary frame on 4 points. Once the villa got to site, then this villa was unloaded and loaded onto the pile caps, and then the support condition changed from these 4 points to the next structure. So when there was this shift in support condition, obviously the whole thing deflects a little bit here. And then in future, during operation, there's a swimming pool on the terrace that is loaded with water. And again, once this is loaded with water, there's another. So all those movements had to be taken into account, and we had to run the design on all these different deflected conditions to make sure that we had enough allowance in the system to accommodate all these different movements. In fact, Vitroxa had to design a project-specific head track for this project to make sure that at the top of the door there was enough movement allowance, because during the unloading, especially the loading and unloading, there was quite a bit of deflection at the head beam. So just talking about a little bit now about the construction process. So once this project was awarded to a company called Grand Craft Industries in Dubai, they've done the structure steel and the shell. During the tender period, a bunch of contractors that bid for the project, they prepared samples to present. So this is some of the samples that were presented during the bidding process. So this sample includes 2 welded lines. And everybody got really excited and said, that's great, it looks great. But the question on everyone's minds is like, okay, this is a small sample. Can we replicate that on a full-size villa? So the samples started getting bigger and bigger. So, at the openings, this shell, the stainless steel on the shell wraps around the opening. So we always knew this was a very critical detail because it wraps around in twists, and you had obviously, the welded joint along this whole face here. So we started requesting for bigger and bigger samples, and then at a certain stage, it was like, okay, I think they got it now. I think we're happy, and everyone is actually quite impressed with the quality that could be achieved. So on the fabrication on the shell, so this is the ellipsoid shape. So this shell was divided into 4 typical panels, which essentially means that there was 4 molds that were created to create the double curved panels. Grancraft, they would manufacture all the molds out of MDF with a 6-axis CNC machine. And the method used for the double forming it's called stretch forming, which basically you have the panel over the mold and you stretch the panel over the mold until it takes the shape. Obviously, this process takes a few rounds because there's a bit of rebound after you let the panels go. So they had to adjust the molds until they got the right rebound to achieve the shape. Once the panel was formed onto the 3-dimensional shape, they would use a laser cutting machine that has the ability to cut 3-dimensional panels, to cut the panels to size. Then they've developed a bunch, of polishing, panel-specific polishing machines that would do the first polishing to achieve the first, the set of mirror polish finish for the sheet as a whole. Once the sheets were fabricated, they would be shipped to the assembly facility in Al Hamria in Sharjah, near Dubai. And then the panels would be assembled into the frame, and they would start welding the panels together. So, that's just some images of the welding, but the real work came with the polishing. So after the welding was done, they manually grinded all the panels and polished and polished and polished. And this is an image of the first benchmark villa that was produced. So there was obviously a few rounds of benchmark that they would present, and we would all come and see, no, it's not good enough, it's not good enough. Eventually what they did is they've removed the villa from the fabrication facility to let it be on open sky. They built a pond under it, and then everyone was really happy. Because the problem is, obviously, it's really good quality, but you can still see a little bit of the welding mark. And obviously, when it's reflecting the roofing full of straight lines, it happens the same thing that happened with the zebra board. All the deformations become really apparent. So the minute they move the sample on the outside and they put the water, all the deformations were gone. So it was, everyone was very happy with the results. And this is just a picture of the fabrication line, so you guys have an idea. There was 3 of those ongoing simultaneously. Okay, so then like I said before, the approach for this construction was to have as much as possible fabricated off-site. So everything was done in Sharjah and shipped or put on a ship container. So we had structural steel, the stainless steel shell, glazing works, MEP ducts, swimming pool, and a little bit of the internal works prefixed onto this villa before it was shipped to site. The total weight of the construction was about 115 tons. Once it was finished, they would wrap it around, seal it, and then put it on the back of a barge. Now, this is the construction facility where it's located, so in Sharjah. So they've hired, they built 3 warehouses here side by side, and it's conveniently by this canal that has access to the ocean. So it made the loading onto the barge is very easy. If you see here, I got this photo from Google Earth during the construction, and you can see here the shells shining at the end of the production line. So once the villas were ready, they would load 4 at a time onto a barge. The trip to KSA took about 22 days. once they got near the site, they would load the villa onto a smaller barge that could navigate the shallow waters. And then finally, so here you see they still, you still have this temporary support here. So then finally unloaded into the pile caps on site. That's a photo of the first villa installed, and this is a more recent photo of almost complete set of overwater villas. This is just some more recent photos from the site, as it looks. That's probably a month old now. So it's almost finished. I think the plan is to open the hotel next year. So just before I finish, just summarizing my experience, my personal experience working on this hotel. So, it's not easy to work on a project like this because it's something that has never been done before. It's very innovative. Everyone is criticizing, like literally everyone. Everyone that would come and see the project, they would find 100 things that could go wrong. So I think one of the things that I think it was really good is that the design team were very close. So we were very close with the architects, with the engineering team, very close with the client, which is really, really important, and also with the contractor. Because when you work on something like this, there will be many challenges along the way, and you need to have a good connection between you and the design team to support each other. And, if someone comes with an idea that is outside the box, that's probably the one idea that will work. So it's just be open to ideas and try not to criticize, because the amount of critics from outside was huge. And like I said, once the project went out for tender and we shared the documents, everyone, this is never going to work. This is, So it's important to have a really good relationship, so you can kind of get support from each other, on these hard times, and support each other's ideas to make it happen. So that's it. Thank you. Thank you.
Thank you, Michelle. Thank you, Michelle. That was a fantastic presentation, and hope we all get invited to come and spend some time in this beautiful, beautiful resort. And you mentioned about collaboration, and I have to also mention Glassline, who was the metal builder involved in this project, and I think they did a great job making sure the glaze.
Yes, I forgot to mention all the people involved. Yes, so Glassline was the facade contractors.
They did a great job, and really, I'm so glad to see this project coming into life and moving into commissioning at the moment. If I have to ask you, and coming back to the theme of today, to think global and build local, how do you find women driving construction today? Where do you see women playing a stronger role in the building construction sector?
Where do I see, or
how do you see women pioneering such wonderful projects?
I think, we had this conversation before, and everybody asks me, how is it working in the Middle East as a woman? I never had a problem there. I always felt that, they're open to listen. I think maybe because, and I'm sure every woman here maybe agree with that or not, but because we kind of build up from a young age, maybe it's inherited that women, so we always have to be 10 times more prepared than a man would, because we know we're going to get challenged. So, we're just doing our job and perhaps trying to be a little bit more prepared for when we're challenged. But it's not, I wouldn't say, I do anything special. I do the same as everybody else. I don't see that there is much difference. There's difference, obviously, between women and men, yeah, but I don't see in terms of competence or, it's just that I think women, because of the way the industry has been, we tend to be a little bit more prepared because we know we're going to get challenged. So, yeah, hopefully the younger ones will also be prepared.
Absolutely, and for the ones watching online and everybody, I think it's a great testimony for your leadership, and we'd love to see women take more and more role in leading such fantastic projects. Ladies and gentlemen, a big round of applause to Michelle. Thanks a lot.
Thank you.
Thank you. Thank you. All right, from the city of Dubai, now we move to the city of Aachen. For our next speaker, she's an architect who has graduated in 1999 and ever since been working at Katowice Phil Architecture. She became the member of management board and became partner in 2016. Our next speaker, Jasna Moritz, is responsible for strategic and content-related support of various projects with a focus on sustainable construction. One of her recent projects, the Moringa project at Hafen City, Hamburg, is one of the first high-rise residential cradle-to-cradle project. She's a partner and member of the executive board at Katowice Phil Architecture. Ladies and gentlemen, please help me welcome Jasna Moritz. Jasna, the stage is yours.
Yeah, good evening. Thanks a lot for that friendly introduction. And well, I'm still very, very impressed by this futuristic design from Michelle, shown by Michelle. And I'm afraid I have to take you back to the past even, because we will speak, or I will speak mainly building in existing context. And first of all, I would like to introduce our office. We are based in Aachen, close to the Dutch and Belgian border, and we're about 120 engaged colleagues there and 40 more in Berlin. Two project offices in Munich and Cologne. This is a picture of our executive board. At the two sides, Gerhard Wittfeld, founder and managing director, Kilian Kada, managing director, and us three partners. Since 2021, we decided to change our internal structure, and now we are 9 associate partners and 25 associates. And our working approach to proposal is what we call working dialogically. So what we are doing is taking a lot of, probably the most perspective to a proposal as is possible, and to consider all the different interests. So this is how we are processing, and it doesn't matter what we are building. It can be an expressive architecture, it can be a quiet architecture, it's always relevant. So we would say architecture means to act very responsible, especially according to the different interests. And the most challenging topic right now is how do we realize really climate-friendly buildings? And we are a young member of the German Sustainability Council, and we did already or experienced a lot of different certification systems, and were very inspired by the C2C design concept. And I think it's very important in the beginning of a project that we discuss what kind of perception we are having on sustainability, because it's really very diverse. And so we are discussing that very profoundly, and we cannot achieve 100% of all of these topics. So this is a process that we put a lot of focus on, especially at the beginning of the project. And as you see, renovating of existing buildings is one of the biggest impact on decarbonization. So I would like to show you our central cross project. I'm going a little bit deeper into this project, refurbishment planning, and have also focused our flashlights short on 5 different and more projects from different stages. So this is our Cologne project, located on a very high frequented crossroad with a direct connection to the main station and to the Cologne Cathedral. And of course, everything is, especially around the cathedral, is related to this World Heritage and should be considered carefully. And we could convince our client not to demolish the building. It's it was he could build a more high-rise building on that side, and but we said, okay, we want to work with that substance and structure which is there. So the client Proximus and Quantum Real Estate developer, you see the normal or usual problematic situations of these very unattractive ground floor areas. We have the metro station around, and so we decided to give the building a new appearance in pinstripes, kind of more elegant, to make it more elegant and to create more space, more generous space in the at the ground floor, to create addresses, new addresses for the building, and to activate the roof services, and also to optimize the functional offers. And what is also a kind of complex situation is that of the regulatories of height or altitude, so that we tried to make the most out of the usage area, and so we came to this staggering of volumes in the extension building. So the yellow part is the one that will be demolished, the flat one, and we have these new extension volumes, also creating a new courtyard and activating the roof terrace. So this is the view inside. So we will remove the parapets, not only to gain more light, but also to offer the required load capacities for the double facade, which is having an important impact on the noise protection. And yeah, we are saving 70% of the existing structure. So that means 2,000 tons of CO2 less then, and even less transport and less emissions also during the construction phases. And the new address, we were trying to emphasize the corner situation, giving it more generosity and space, and a two-story foyer. And with this staggering also along the road, we are creating more urban space and with a more open and transparent appearance. So the extension building, we have very low story height. We try to compensate with that kind of in the extension building. And here you have an idea of these staircases connecting the two. And we try to give each story an outside. Is here a small loggia, trying to create new internal connections, direct connections. And of course, the potential of the rooftop with the fantastic overview over Cologne, and especially on the Cathedral of Cologne. This is a graphic that shows that each story should have an outside quality in terms of different offers, like all the terraces, all the offsets are creating new terraces where people can connect and come together and work. The courtyard, which is very green also. And the ecological added values are diverse. Of course, we are trying to bring out as much as possible. We have a certification aim. And what is always plays an important role to us is to really look at the local passive potential of the sites. So we're trying to we will use the wastewater heat, and we will also try to optionally use the heat and the cold of the metro station. And photovoltaic, everything, rainwater retention, what modern building should offer. And here in section showing the height of the existing stories, it's just 2.70 meters, And you see with the extension, we're trying to compensate with a little bit more height than in a kind of in different ways and different steps. So the technical concept is like by creating less altitude for the infrastructure, we're using or working with induction units, devices for hold and heat supplies, and also for the ventilation, decentral ventilation, so we can put the infrastructure in the cavity floor and also in the place above the moving area, so the working area will be free, just adding this acoustic absorber layer above, and the other infrastructure is running alongside the facade. One more detail for that. And the basement store used to be a parking lot, and now we are able to implement 150 bicycles and offering all the devices and services that a modern bicycle garage should have. And we still love to work with physical models. A lot of every project we are building these physical models and are considering it together with the team. And here are some impressions for the facade. It's the double facade. We are the windows can be opened and then offer this comfort ventilation individually. And we are supported by Dres and Sommer, the facade experts in Cologne. And of course, I want to show you also these beautiful details. So here you can see that this staggering is kind of design idea for us to deal with on different levels. So we have these volumes of the extensions, staggering across along the street, but also in the ground floor area, but also in a smaller scale at the opaque facade, at the extension, and also at the double facade. So the simpler one facade in the extension, which should, with this double pilaster, is trying to emphasize the verticality of the project. One more detail. And now I will come to our focus, our short flashlights. The first project is a very old one. It's the competition was in 1999. It's the central station of Salzburg, and we won the competition in 1999, and it took us 10 years for planning. So it was quite complex to convince also the monument preservation offices for our design, and it took then 5 years for the realization. So you see 3 eras, 3 roofs, and one main challenge was that we should switch from a terminus station to a through station while the operation of the station was going on. That was quite challenging. And the second main task was to connect these 2 different districts together. So we have a dynamic, we have this passage level on the ground floor level coming from the main station side, and we have these new linear dynamic tracks above. And here, in first impression of this historical entrance hall and the platform, the old historic platform hall from 1999, which we implemented, and it was important to us to have one big design for this new roof on the top of the main station. So it was a kind of substantial refurbishment for the historic part. And here a model of the platform hall, the old one, and we built a lot of models and try to look how we can combine them together so that the new roofing is not stealing the show to the old structure. And this is what it's today, and it is located differently, and it looks quite natural right now, but it was really a huge effort to restore it. And it took us a lot of convincing the monumental preservation offices that we can change the color of the construction. But it was very important to us to have a really light and natural, as much natural light and a bright railway station, so that people feel welcomed. And we were really pleased that the Austrians, they chose this railway station after realization for one of the most beautiful stations in Austria. So that was a nice feedback and motivation for us. And we could only take a membrane construction for the roof covering. Any other structure would be too heavy for the very filigree construction, steel construction, and it was also the pneumatic thing that we could react flexible with the snow weight, which is quite important thing in Austria. So but we also liked a lot the transparency of this construction, which was also very important for us. And here you have an idea of what I'm talking about. So here on the right side, you see the new roof for Schalmoos, the district, the neighborhood district, and it's implementing also bicycle services and a garage for bicycles. And it's also a generous space, so hopefully welcoming space and entrance to the railway station. The second project is a refurbishment of a former office building in Cologne, quite close to the main station and the Cathedral of Cologne. And it was a railway company building, and yes, located very close to the river Rhine. And we decided to shape the old silhouette, the old contour of the mansard roof that was destructed on the World War, in the Second World War. And so also we were also implementing old historic important elements into the foyer, the flooring, and with these horizontal aluminium stripes, we can describe the contour, the old contour easily. The thermal facade is offsetted so that we can offer new balconies and a fantastic view to the river. We did the signalétique for the tenants, a European Union aviation, and so it's now finished. I mean, I think in 2016. So this was our approach to give these stories their own identity. And that's what it's in nowadays. Now a small scale change. It's an archaeological pavilion in Aachen. It's built or finished in 2013. And also a very representative location in a very important small inner city park in Aachen, and we choose this elliptical form according to the landscape design, and we implemented a pathway also through the pavilion. And we were inspired by this layering pattern of the 5 eras, 5,000 years of layering historical, archaeological things, and this inspired us for this construction, which is also it's the facade of the small pavilion, and you have this window into the past, which is quite nice to discover. And the challenge was not to touch the archaeological, with the foundation, the archaeological finds in the earth. And so we built a simple steel frame and with flexible micropiles then. And it was very nice. It was supported by a local company, and it was nice to see that they are identifying themselves with the project. That was nice to see. And here you see that it's really a light and very open construction, and yeah, people are still relaxing at that spot. So the fourth project is a bank house also in Aachen. It's vis-à-vis to the old theater in Aachen, also close to this inner city park. And yeah, it is always fascinating for us to work with unique historic elements and to combine them and bring them with new, so kind of innovation and tradition, bring them together. And so we think that, well, our approach is more like an equal relationship between both the old and the new one, so to strengthen the identity of the place. And it was also important to have transparent and overview to the old theater, which is very nice and an indoor quality. So we took also the 4-meter high, yeah, from the historical building. So we could convince the client not to bring one more story into the project, but to look at these, watch out for these structural impacts that are already there. And yeah, of course, the roof contour, we took the old one, but realize it in a way that we also gain the more usage space as possible. And the last project is our actual planning for the Komische Oper in Berlin. It's a cultural institution. It's one of the 3 music theaters in Berlin, and here the opera hall itself is a neo-rococo atmosphere, and originally still there, but it has to be renovated carefully. And you see, it's located also on a very prominent site. It's quite close to the Brandenburger Tor, and it has a very rich history, and it used to be integrated into a block structure, and right now, and after the Second World War, when the surrounding was demolished, it came out to be more a solitary building. And the new functional services that were claimed, we created them or put them into these different volumes that are reacting with the urban surrounding in altitude and also in the diversity of uses, and that are creating new addresses. And this is kind of so the place of metamorphosis. So the existing building is really a very good example for metamorphosis. And right now we are showing these different uses with our different volumes then. And it's a very compact, a very dense program, also very complex in its different requirements. And so the stage tower should have 5 more meters for the technical issues, and so the rehearsal rooms should be free of columns, and that was also quite challenging, also in terms of structural engineering. But we are approaching, and thanks to a precise 3D model, we are hopefully coming to our how can I say, reaching our goals with it. And yeah, you see these facade collage representing these different uses and the different volumes once more. And so the pattern or the materials for the facades are in different materials that we are referring to what is already in the old building. So we have this limestone, we interpreted it into this concrete wall. We have ceramic and material mesh, metal mesh, and yeah, here especially the corners with a very open and transparent situation for the ticket shop, and there's a cafeteria on the other side. There will be a gastronomy, so we will be offering also the public a lot of new addresses, and yeah, 3 centuries in one building. And we think that the roof terrace is having a drink on the new rooftop bar is also a kind of added value for all Berlin inhabitants and visitors. So as a conclusio, I would like to speak about these 5 claims that we have. So it's always important for us to read the history, to have a profound analysis, to look carefully and transform carefully. It's to recognize the unique thing and to feel inspired about the historical structural things that we find. So it's hopefully it should be a kind of unity, but also preserve diversity. And it's always a kind of collegial coexistence of the old and the new one. And it's also really the time for optimization, so we can take a deep look into the project and see, watch out what is going well and what is not running so well. So it's also a very important thing for optimization. And as we have a very green heart in our office, so we are absolutely convinced or believe in as much green as possible. I wanted to show you some of our more green and different projects we are working or already been finished. And last but not least, it's we think that it's very important in nowadays to to think outside of the box. We cannot think in silos anymore. We have to talk to other disciplines, to sociologists, scientists, engineers, to learn more about our ecosystem, because climate protection is really has no borders, and so we are trying to have a look, watch out the innovation potentials of digitalization and also which tools are coming up. So we have to rethink the quality of our simulations and of our software. So this is a very dynamic process, and last but not least, very important to us is our networking. So to have a look what other disciplines have already learned and to learn from them, because we still have to learn a lot about sustainable buildings. And I would like to end with this small drawing from Kilian Kada. So we are adding or generating added value, but and it is really worth it. So I think that's the end. Thank you for your attention.
Thank you, Asna. I think it was so nice to see how you've embedded sustainability in all your projects, and absolutely, it's definite value add. And this year we are having this COP28 happening, all about climate change and climate action. So it's really impressive to see the kind of work you're doing in that direction. So thank you very much for that.
Thanks a lot.
And my question to you regarding all the audience, young women architects who are aspiring to succeed and grow in life, what would be your one piece of advice you would like to give them?
Well, I would say it's it's really stupid not to look from the perspective of 50% of our human beings. I mean, the women. So it's really important, I would say, to have, especially in leading position, to have women, to have this different perspective on the tasks, and especially also on sustainability. So I can only say it's an encourage and it's an enrichment, and every company that is not doing so is really missing something very important. So. And the young women should really get out of their comfort zone and try to risk a little bit more, maybe. So this is what I can say.
Thank you so much. Ladies and gentlemen, Jasna Moritz from Katowice Architecture.
Thank you.
All right. For our next speaker, she hails from the Scandinavian lands. She studied architecture in Germany, graduated in 2015. She worked 3 years in Jörg Ingels Group as a design assistant and junior architect before she became the design lead. She has gained a master's degree in architecture at the Royal Danish Academy and rejoined Jörg Ingels Group, where she designed the project The Plus and other timber construction projects. Jörg Ingels Group needs no introduction, but for still people who would like to know, they are formed in 2005, headquartered in Copenhagen, and having 700 people working worldwide. Ladies and gentlemen from Jörg Ingels Group, please help me welcome Victoria Millentrup.
Yeah, thank you very much for having me here. So I'm representing, I guess, Scandinavia, since I'm living in Oslo now, and we just opened an office there. So I'm the head of the Oslo office. We are a lot of people all over the world. We have an office in Copenhagen, one in Barcelona, one in New York, one in London, and Shenzhen and Oslo. And in our office, we are combining not only architects, but construction architects, which is a different category of education. So we have architects and we have construction architects and we have engineers. So there's something in between. I'm an architect, so I'm clearly the design part. We have a lot of people that are sitting with coding and programming and doing all the analysis for us, climate analysis, and we have engineers and we have also landscape architects in-house. I just brought a little bit of projects also before that were like recently finished. We are working a lot with Google together. This is the Google Bayview in California. And I just brought this up because it's maybe one of our projects that has the more like special facade to it, because it's trying to be carbon neutral, and so it has like 55,000 shingles of solar panels on the roof. To harvest the solar energy, and it's creating actually 7 megawatts of energy in total. We recently finished the spiral in New York. You can see that's more like all-round glass facade, but this kind of balconies are wrapping all around, continuing the park from outside to all the way up to the last floor. This has like 66 floors in total, and is our highest high-rise so far that we built, so we're very proud of this. And this is one of our older projects, which we actually started with was housing, social housing in Copenhagen. Some people might know it. This is basically what Bjarke Ingels started with. There were 3 competitors. They all designed something for each site that you can see. And Bjarke Ingels decided to design for all 3 of them and present it at the very end, and he got all the sites. And this is how he got big in the beginning. This was basically a parking lot where you can park right next to your apartment. So you have this kind of triangle of parking lots stacked on top of each other, and on the other side you have your apartment with the nice views. Everyone has like a single garden, and it worked out very well for him from then on. I'm here today because I'm talking about the Plus. That's a factory in Norway. This was my first project after graduating in 2019. I'm very sorry because it's not always all about the facade, even though some people might think that of big, but we actually also design the insides. So I'm going to show you a little bit more about the background of the project and of course also the facade. So this is my boss. Maybe you have seen him before. And on the right side is the client. He was 35 when he approached us that he wanted the most sustainable furniture factory in the world because he's a producer of outdoor furniture. This was the team in the very beginning. So you see some of our engineers, some of our architects, some of the partners, and me as well. Right, freshly graduated from school, and the model in the middle. This is how it all started, you know, like you just have a model and you never know if it's going to be built, but fortunately enough, it was built. It's called the Plus because it's quite obvious in plan view it is a plus. This was when it was started to be constructed. That was in the wintertime. In Norway, they also build in the wintertime, even because otherwise they wouldn't build half a year. All the concrete was poured actually in the winter time, and then we started constructing, and after 17 months we had the finished factory. That was last year in March when it was finished. This is how it looked last year in March, and the factory is actually right between the steel factory of Vestre, that's the company that's producing the furniture in Sweden, and their headquarters in Oslo. So right in this middle part on the Swedish border is the new factory, pretty much in the middle of nowhere. You wouldn't find it if I wouldn't point it. They produce sustainable outdoor furniture already for like a lot of decades because this company was actually established in the 50s. So it's running in the third generation as a small family company. And this is one of their furniture pieces. And they came to us and wanted a factory that is as sustainable as their furniture, which is very interesting because we had to reach BREEAM Outstanding, and there hasn't been any factory in whole Europe that has ever had a sustainability standard that high. So we had no prototype whatsoever. Then we had to look at the factory typology because the client said, okay, what you usually think of a factory is something that is dirty, that is polluting, that is fenced off, something where you can't look inside because people are hiding what they're producing. And he wanted something that is green and transparent and welcoming so everybody could 24/7 come to his factory, look inside and experience everything that is being produced inside. We have a law since the 1st of January this year in Denmark that everything that is called sustainable, a sustainable building over 1,000 square meters, if it's not reaching at least 12 kilograms CO2 equivalent per square meter per year with an LCA, then you're gonna be sued. So if you say that something is sustainable in the building industry in Denmark, you cannot do that anymore, which is quite nice because this word has been a little bit overused. We used a bio-based load-bearing construction, which is wood, not only because this gave us the standard to reach BREEAM Outstanding, which is kind of the highest degree of DGNB, just that's the system that they chose in Norway, which is a British system. And also because Norwegians are very good with building in wood. They know what they're doing, so it's something that everybody knows there already. So it is a Norwegian passive house. That's a different passive house than in Germany because it's way colder in Norway, so it has to be even more fluffed up. And all the facade area is basically based on this passive house standard and at the same time getting enough daylight for the working conditions inside. Why is it a plus? We have those 4 factory wings that the client wanted. So you can see that there's a warehouse, a wood factory, a color factory, and an assembly. So the wood is basically getting into the warehouse, it's going through the wood factory where it's being CNC milled, and then it's going to the assembly. The same goes for the steel that is coming from Sweden. It's being color-coded, powder-coated in the color factory and going into the assembly, and then you have a finished furniture piece that is going out of the factory. So we have 2 production rows that are going through each site, and that's why the factory is built up like this as a plus. In each wing, we have an MEP corridor. All the machineries and all their, like pipes and whatever comes from them is going into the ground and going into the MEP corridor. It was very important that this factory has no backside. So you can walk all around. It has no pipes coming out of it or machines that you can see from the outside. So everything, like ventilations and even dust extraction, is in this MEP corridor. We have this, what the client called the German Autobahn in the middle. So all the forklifts and all the conveyor belts, they're going into this middle lane and they have to be kind of translated throughout the factory. This is how it looks. So you see the conveyor belt at the top. I come a little bit later to this whole color part, why it's all colorful. But you can see that those colors from the different factory wings, they meet inside of this roundabout. And you see that there's an inner courtyard where you can also, as a visitor, go down and look inside of the factory. Then we have, as the 5th program part, we have an office and an exhibition, but that cannot basically destruct the office flow, the factory flow, so it's lifted above. And this is also how the factory got its shape. So you basically have this office floor on top, and at the same time, you want to still look into each factory wing, but also still out in the forest, because we are in a 300,000 square meter forest, which is nice. So on top, you can kind of see how it looks. You either look into the factory or out in the forest, and that's why basically the roof from each wing is just picked up one corner and adjusted to fit the office on top. This is the roof terrace, so you can, on 2 sides, you can walk on top of the building and relax on the roof terrace or go down into this courtyard. It's 24/7 accessible, and that resembles the Scandinavian concept of Allemansrätten, which just means Jedermannsrecht, which means it's the right to roam for everyone. So you can get your tent and come to the factory and sleep there if you want. So that's just how Scandinavians roll. Maybe also because they are so little people in the same size as Germany has 5 million people, so everybody can do that. But that's how they wanted it to have. This is basically the wood construction. First, we wanted a portal frame construction, but there was too much wood, so we decided to use the MEP corridor for the cross bracing, or most of the cross bracing. And you can see that it's kind of like this reciprocal structure. And I'm also always explaining this like this. So each wing is resting on the other one. If you take one wing away, the thing would collapse. So that's how I usually explain reciprocal to people that are not usually used to it. The CLT that we use is storing more than 1,400 tons of CO2, which is a nice number, but timber is not sustainable to use if you don't know where it's coming from, and that there's also, sustainable forestry behind it, and that you plant trees again when you take some of them out. So we made sure of that. We have this courtyard in the middle that is green and is also at the same time the exhibition space for Vestre, because they make outdoor furniture, so it's nice to have the furniture kind of in this outdoor plaza. The green roof we added because we sealed a lot of forest floor, because usually a factory is kind of a one-floor thing. You use up a lot of space, so you try to give it back. And as you can see, you can walk up to the roof, and in the coming years there will also be a trail that is making it possible, if you have a stroller or you're on a wheelchair, that you can also get up to the roof. These are the tough ladies that took all the plants from the neighboring fields and put it on the roof. So you can see that's basically our 5th facade, if you may say so, because we are looking onto those roofs from the roof terrace as well. So it was very nice that they made a real effort to take plants that were coming from the site. At the same time, those plants are helping with like solar gain from the solar panels because all the green on the roof is cooling the solar panels in summer, so we have more solar gain. Yeah, this is this tiny place called Magnor, where the factory is actually standing. The factory next to us is actually Norsk Hydro. So we have a neighbor, and they were happy to have us because this whole area of the 300,000 square meter forest would have been an industrial site, all concrete and one factory after another. And then Vestre came and said, like, I'm going to save this forest, and there will only be me and Norsk Hydro here, and we're going to revive that forest and make a park and make also the circle back into Magnor. And Magnor has, I think, 463 residents. So you know how tiny it is. So they were very happy that there is a workplace and, you know, the village is getting up to speed. This park will develop like different unique furniture pieces of Vestre. So they have different furniture pieces that are maybe elongated or scaled up. And exactly like this looks on the plan. And then in the course of time, we make some kind of visualization like this to just understand the logistics of the factory. So basically what you see is the logistic that works best for the factory and the factory flow, and that's why it has this plus shape. So you see in blue, you come in with the trucks, and they bring the steel and they bring the wood. It's going into the wood factory in one way, and it's going to be CNC milled and cut to pieces, and then it's going into the assembly, and the same goes for the other side for the steel, and the steel is being powder coated. And then on the other side, the trucks go out and bring the finished furniture pieces into the world. Here you have the office floor, and you see the courtyard inside. And that's basically the finished building. It is self-sufficient on sunny days in summer, because we're in Norway, there's not always sun. So it's very important to say that, but the client was very demanding, saying that he wants to give back into the grid. He doesn't only want to take, because they're already running on hydropower, so he doesn't need to do anything to actually be green, but he wanted to have solar panels anyways. And we have this kind of readable production flow, because it was very important for the client to have any age and anyone coming to the factory and being able to understand the flow of the factory and saying, like, you follow that red line and you see the CNC mill, for instance. This is how it looked in the beginning, when we rendered it, a bit more colorful, and this was the wood factory in the end. The wood factory was actually brought by a German company, which I had to call and tell them 5 times, yes, the machine has to be pink, which they didn't believe me. And in the end, they did it, even though they were not very happy about it. But there you see it, and I think it works actually quite well. And then the color factory is in green tones with this kind of robotic powder coating. And then we have the assembly in yellow. And this view was very important for the client, because he wanted everybody to come and see how production is working, and that it's fun, and that you can be inspired by it. And that was actually the first picture that they gave to us, how they imagined that their factory would look like. Of course, there's no structures, there's just windows, which would be nice for any architect, but we couldn't really do that. But this effect that you ride next to the forest was always present, so we tried to keep that. We have the facade. The facade is a burnt wood facade. Now you can ask, why did we choose that? First of all, because we're in a forest and we wanted to keep this kind of wooden topic. We wanted to keep timber as our main facade, but then you can oil the timber, you can wax it, or you need to paint it on and on again, and we have a lot of closed facades. So for us, it was very much maintenance decision, and this very old technique that the Norwegians and the Japanese people used for like centuries is actually to char the wood, and it lasts for 60 years without any maintenance. So we use that, and that also tells us a little bit about that it's not always new technology. We also go back and see what has already been there for hundreds of years. What can we use again and rediscover? Yeah, we have an LCA-driven facade. That means that we had a lot of trouble getting the right amount of window area to get enough daylight in for basically the working rules, but at the same time be a passive house and have the energy standards of having not too much of glass facade. So the glass facade that you see here is exactly the amount that we could afford for both to kind of meet in this golden area. Yeah, it is circa 75. It wasn't 100 back then yet, so it was only 75, which is very sad. But right now, of course, if I could update it, I would, but that wasn't the case. It was expensive enough, so I think we cannot do anything anymore. The facade is actually 5 meters away from the trees, which is very close, which the construction company doesn't like so much because they like to come with the big machineries and they make a lot of place for all the stuff they have to store. But that's the client, and he saved every tree that was marked by the construction company that should have been taken away, but that was basically further away than 5 meters. So he demarked it. He's now the Norwegian Minister for Trade and Industry, so he's the Robert Habeck of his country. So if you build a factory with me, I can bring you somewhere, I guess. Yeah, the cut trees on site, the minimum amount that we took is used in the subconstruction. It was not mature enough to be used for anything else. So you cannot see it visibly, but most of it was used. We have a CO2 reduced concrete mix. That means also, like, if you take a section through the whole building, you see different heights of concrete because the machinery is sometimes more heavy and sometimes you don't need the load bearing. So it's a mix of both. We have the CLT from local resources. It's spruce, which is kind of common for CLT. We brought this one out. As a German, I'm very proud of it because this is Detail magazine that made this monograph, and my project is in it, so I can basically retire because what do I want more as a German to reach? Here, like a picture when they mounted the facade. And in this book, you can also see all the details because we're usually getting told that we cannot develop details. And now you can actually look them up and see that they are maybe not always good, but these ones are very good. This is usually how we render the facade before. This facade system is like 1 meter wide, just because we wanted to have steps that are following the facade up to the roof and also inside. So in that book, you can basically, that are also broad. Maybe Christian will just take it out and show it to people. There we have all the facade systems in and how we usually kind of develop them. Also for the courtyard, which is curved glass, which we cannot always afford, but we really love as architects. Exactly, and then also the gates, because the gates are huge glass facades that can basically roll to the side and open for the trucks, which was also very wanted by the client. It's not always the architect only. Exactly, and then timber is of course also good for people to work in or like to be close to. It has a lot of health benefits, which is also part of BREEAM. People underestimate that people actually have a view while they work. My father was working 20 years in a factory that had no windows, only windows to the top. And you could see the effects after 20 years that it had on him. So we should more think about our working conditions, maybe in those settings. This is the kind of daylight factor analysis that we use to choose the window facade, the facade in terms of BREEAM. Basically, this whole system to go through and how much facade can we actually bring to the table. Then we have some skylights in the roof, just because there are certain areas where people are standing more than 30 minutes, and then you have to have a certain amount of daylight over the day. That's BREEAM, so we had to calculate that as well. Biodiversity, this is a productive forest. All the wood that you usually use for construction around here is coming from there. So everybody that's thinking, oh my God, we're taking away trees, they would have been taken away anyways. So this is not that's not a real forest. Everybody that has been in a real forest can see that's not a real forest. So we have to make it a real forest again. We have BREEAM Outstanding, finally. We had the last tick now. We're Paris-proof, and we have also Future Build Zero. A few behind the scenes. This is the team over Corona and after Corona. This is our engineer that's not happy with what's happening, what we did. We do a lot of virtual reality and renderings and stuff, you know that. We also built huge models. The centerpiece of the factory was actually the most complicated because everything had to come together. So we had to model that in quite big. Here's the ramps that lead up to the roof, and this is our construction architect that is not believing that 50 centimeters less is really good. So that's why he's also in tears. We wanted to sink the factory a little bit in, but our client said like, it's not really good if somebody's looking down on you while you're working. It's not the best condition. Then it was a lockdown. 11 months Norway was closed, actually not letting anyone in. So I had my first construction site without actually being there. And when I was there, of course, I started crying. And I was very happy that somebody actually built what I drew. And here we went on site visits. This was like half finished. Went with the boss. And here you see my boss, who's not really convinced with what I did. But I still have a job, so I guess it's okay. And it was the rendering from the beginning. And this is how it basically turned out to be. Now it's also green in summer. Now it's full of snow. And that's it.
One of the best factories I've ever seen in my life, hands down. Brilliant work. I think redefined the way of working workplaces. Fantastic. Thank you so much for this nice presentation. I'm glad to see that you'd used so many sustainable material, local material, Circal. Brilliant. Well done.
Now to the women.
And now to the women question, right? I mean, as an architect, moving around places and taking on this project, what would be your piece of advice for young women architects who are venturing into a career like this?
Move to Scandinavia. They always live it ahead, you know, like you don't have to pay. No, it's. I would say, you know, I think in the beginning I was a little bit afraid that people know more than me, but then after some time you just realize, no. So it's just about always being open-minded, asking questions, being like I didn't think about me being a woman in architecture really much the last 8 years that I was working in Scandinavia. So I think it's not really a question anymore, and if it doesn't become a topic anymore, I think this is where you want to be ending up.
Fantastic.
Yeah, so that's my point of it.
Thank you so much, Victoria. May I wish you many more lovely workplaces. I wish to see such buildings all over the world.
Thank you.
Ladies and gentlemen, a big round of applause. Victoria Minatu from the big group. All right, for my last, we've saved the best. Our next speaker graduated as an architect in Germany and worked for more than 10 years in Berlin and London, where she worked on a wide range of local and international projects and gained deep experience in all aspects of design. In 2006, she joined Arup, one of the largest multidisciplinary consultancy group, and she became an associate in 2019. And since 2022, Suzanne is the associate director at Arup and leads the German building envelope design team. Ladies and gentlemen, please help me welcome Susan Stoppler, associate director at Arup from Berlin.
Thank you.
you. Yes, ARP is an international operating multidisciplinary engineering company, and I'm here as the building envelope team lead of Berlin. I will talk about some refurbishment projects that our teams in Berlin and London have worked on, and why we think that refurbishment is very important to achieving the climate goals. In order to achieve carbon neutrality by 2050, we need to set ourselves some intermediate targets. Climate researchers introduced the so-called carbon law in 2017, which defines that we need to halve carbon emission in every decade to ensure that we reach our goals. This is acknowledged as setting realistic intermediate goals so that we can combine short-term measures and long-term goals. In alignment with this, the European Union defines a Fit for 55 legislation, which requires a 55% reduction of carbon by 2030. And some countries define their own goals, such as the German climate law is targeting 65% reduction by 2030. Unfortunately, current data imply that we are not on track to achieving these goals, so that we have to very much improve our effort to get where we want to be. It is a huge task, and we need to ensure that all industries work together, and we have to be very careful that we do not shift carbon emission from one trade to the other. Of course, we have to move away from fossil fuels and renewable sources towards renewable sources. But we also need to make sure that we only use as much energy as needed, because also the capacity for renewables is, of course, limited. And at the same time, we have to minimize the upfront energy consumption during construction, because this alone is responsible for up to 12% of the overall carbon emission. If you look at the energy consumption, the picture is quite similar. More than 1/3 of the energy consumption goes into buildings. And for the in-use energy consumptions, 3/4 go into heating, and the rest goes into warm water, lighting and cooling. This clearly shows that refurbishing the building stock is a key task to achieve the climate goals. And the existing buildings play an important role in the decarbonization process. If you look at Germany, we have currently 22 million buildings. 19 million of these are residential buildings. And up to 90% have been built before the first energy saving regulation in 2002, which clearly shows that these will need a lot of improvement if they want to contribute to the climate targets. But refurbishment is not only about reducing the energy consumption and reducing carbon emission. We can also have an opportunity to make buildings healthier, reduce hazardous materials, and make buildings greener and improve the quality of the surroundings. We can also make buildings more accessible and therefore fit for an aging society. And we can introduce charging points for e-mobility so that they can help change the mobility strategy. On a wider picture, refurbishment allows buildings to be made more resilient against climate change. And perhaps most important, they can reduce the requirement for greenfield development. And therefore, we can help preserve nature and biodiversity and also agricultural areas. But with such a large requirement for renovation, there are also some risks involved. The biggest risk, of course, is that we miss our chances, but we also need to make sure that we reuse the large stock of resources that's inherent in the existing buildings, and that we use new resources efficiently, which means that we have to implement life cycle thinking. The first building I'm going to talk about is Haus Neumarkt, a building in Cologne. This is obviously a historic building picture. The building was built in the 1950s and has a special significance for the Cologne city center because most of the post-war buildings have been demolished, and the awareness of the heritage value has only been developed in the recent years, and therefore most of these buildings have been at least partly or completely listed. After the renovation in the late 80s, the building had completely lost its original character, and the client polis initially considered demolishing it and building a new building. But he then decided to preserve the Haus Neumarkt and make it fit for the future as part of an energy revitalization strategy of their portfolio. Arup was commissioned with the design of the building envelope and building physics and acoustics consultancy. The reconstruction was carried out in line with the historical preservation requirements and in close cooperation with the conservation department. Since the renovation in the 1980s left some irreparable damage to the facade, the external facade had to be completely demolished and reinstated. The redesign was based on historical documentation, and it was important for us to reinstate the three main characteristics of the post-war building, which were the typical three-part Cologne windows, as well as the characteristic black glazed spandrels, the slender sidelines, and the slender stone framing made of Jura stone. But of course, we also had to take into account modern building regulations and thermal and acoustic performance. The design drivers for the development of the design were keeping the facade profiles as thin as possible, minimizing the facade weight because we had to make sure that the existing structure could still support the new facade, and reducing the energy demand, which means, of course, improving the thermal performance. One of the greatest weaknesses of post-war buildings, unfortunately, is the poor thermal performance. So this had to be enhanced. To avoid affecting the slender frames, we have pushed the facade slightly outwards so that we could provide a continuous thermal line, and we could also improve and enhance the insulation of the spandrel zones. And therefore, we could provide a proper and appropriate thermal performance. Due to its location in the city center and near a busy traffic junction, we had to achieve quite high acoustic performance requirements. And therefore, our acoustics team carried out some very detailed measurements to ensure that we could optimize the glazing so that we could achieve a good acoustic performance for the users, but at the same time minimize the weight of the glass, which, as I said, was important for the supporting structure, but also from a sustainability standpoint. This is important because we want to avoid over-specifying and just use as much material as we have to. A thorough material selection process has been established in close cooperation with the Heritage Department. And because we used a lot of valuable materials on the building, we made sure that they will be able to be reused after the end of the life of the building. So we avoided using composite materials, and we made sure that all materials could be easily disassembled. And we designed simple plug-in collections that allowed a simple reuse at later times. As a large amount of the building substance could be maintained, we could save a lot of carbon emission. And just by reusing the reinforced concrete structure, it was possible to save about 1,300 cubic meters of concrete, which is equivalent to 2,500 tons of carbon. The next building is Coal Drops Yard in King's Cross in London. This project gave new life to 3 old cold storage buildings behind the King's Cross station. The site was built in the 1800s for coal distribution. 3 largely dilapidated historic buildings have been transformed into a shopping and dining district. The buildings are linked on the upper floor with a sculptural roof. Heatherwick Studio was the architects, and Arup was appointed with facade consulting, heritage consulting, materials and structural engineering. In the 1980s, large areas of the roof were destroyed by a fire, so the existing roof had to be replaced, and therefore this was an opportunity to develop this sculptural new roof. The project involved the assessment and strengthening and repair of the historic buildings and the design of the new facades. The existing masonry of the former functional buildings was retained, reflecting the repair and conservation work of previous generations. This design approach is opposed to the demand of perfection and shows respect for the craftsmanship and the former life of the retained parts of the building. It also creates a suspenseful contrast with the new facade and roof, which reflects modern state-of-the-art manufacturing technologies. The upper level is enclosed in a tapering 8-meter tall structural glass facade. It spans vertical between the slabs and trusses and relies purely on the glass and the geometry to support itself. The adjacent 3 glass holders, former glass holders, are now accompanying high-end residential developments with 145 apartments. The architect was Wilkinson Eyre Architects, and Arup was appointed with facade engineering and wind engineering, and also structure engineering. The gas holders were originally built in the 1860s to provide storage capacity for the gas that was produced from the coal. The residential buildings were built within the 3 interlocking former historic gas holder guide frames. The frames were dismantled, refurbished and reinstated, and complex wind calculations were carried out to ensure that they could support themselves and did not have to be restrained back to the buildings. A unitized facade was developed for the building to ensure high quality of workmanship and efficient insulation, and it also allowed that the facade could be erected at the same time as a reinstated gas holder frame. The balconies were always also assembled off-site and installed at the same time as a unitized facade. The sliding folding doors were hoisted in place afterwards. The material and design was selected in order to reflect and maintain the industrial appearance of the building, whilst also achieving modern high-performance thermal and acoustic standards. So in summary, maintaining and respecting the existing building created identity and developed a suspenseful contrast with the state-of-art modern facade on the top of it. Reusing what was left of the original building also allowed to reduce a lot of carbon emission. So the last building I'm going to talk about is the Burrell Collection in Glasgow. The building first opened in 1983, and this is one of Scotland's very few Category A listed post-war buildings. The deterioration of the facade meant that it required copious renovation and repairs, because it needed to be ensured that the artwork was safe and the building itself was fit for purpose. Circularity was on the very heart of the development of this project. Most of the original building materials could be reused, recovered, or recycled. The building envelope included 3,100 square meters of glazing. We worked together with the glass industry to ensure that much of the existing glass was recycled in a closed loop, which means that it could be reintroduced, the colors could be reintroduced and turned back into building glass. We were also able to reuse the existing aluminum frames of the curtain walling, which saved 8.5 tons of aluminium. Detailed investigation and structural calculations were carried out in order to allow reusing the existing facade profiles. The profiles were cleaned, repaired, and the support was reinforced, and special gaskets were produced to ensure that the new facade can achieve up-to-date thermal and weather performance. All in all, we could ensure that 16 tons of glass was reused for architectural glass, 8.5 tons of aluminium was saved, which meant that 80 tons of carbon emission was prevented. And no glass went into landfill. Body tinted and laminated glass, which could not be recycled in a closed cycle into architectural glass, was processed into other building products. So in summary, the improvement of the building envelope contributed with 51% to the overall improvement of the carbon emission and thermal performance on the building, which means is equivalent to 626 tons of carbon per year. So the main measures were the improvement of the roof thermal performance and installation and introduction of PV panels. We also improved the air tightness of the facade and, of course, improved the solar performance and thermal performance of the glazing. But also, we managed to improve the quality of the exhibition space. Frequent feedback from the visitors is the quality of light bringing the collection to light, which is a result of the new high-performance glazing and improved solar control across the building. As a summary, careful refurbishment can largely contribute to carbon reduction, whilst reducing upfront carbon emission and resource consumption. And at the same time, it gives us the opportunity to improve our built environment significantly. Thank you.
Thank you, Suzanne. That was a very nice presentation. And given that so many buildings are aging, I think this gives us a lot of hope that buildings can be restored in a very sustainable fashion. And next time, we would love to take that aluminum back, recycle it, and give it back to you as newer, 100% recycled aluminum.
I was hesitating a bit when I said that we reuse the profiles and thought you might not like it.
There's always a next time. Suzanne, before we let you go, as a young woman engineer in this tough environment, what would be your one piece of advice for enthusiasts, for women in the field of engineering?
I think I agree to everything that my pre-speaker said. I think it's for us, it should become very natural. Just be themselves and behave as everyone else does in our position, obviously. And it's important, I think it's very important that we are well represented as much as we are in the normal society, and bring in our different backgrounds, our different approaches to working in teams and working in a leadership position.
Wise word. Ladies and gentlemen, Suzanne Stoppler from Arup, a big round of applause. Thank you so much.
Thank you
for your presentation. what an evening, right? We started talking about futuristic hotels, and from there we went on to cradle high-rise buildings, and then we talked about the amazing future of factories, how it's going to look like, and to end up with restoration and sustainability of restoring buildings in the best possible fashion. I think we had a delight of wonderful content and presentations today. So let's give a thunderous round of applause for all our lovely speakers who have done a great job today. Thank you. A big thank you for all the Next Studio partners. It's been a great honor to host all of you, the live audience as well. And for all of you watching online, thank you so much for staying tuned with us. We come back next year for the 8th Next Facade Summit. Till then, it's Arvind saying goodbye and good night.
Discover Next, the studio for facades and design. Next is the platform for innovation in the field of building envelopes, for inspiration, information and communication. Initiated by Vicona, with leading industry experts as Next partners. Next is a unique concept which is constantly evolving and bringing the future of cities to life.